Hi everyone, let's see today's question. So today's question is from the topic of matrices, where the question says that a matrix is given which is M, and that matrix has the elements sine raised to 4 theta, minus 1 minus sine square theta, 1 plus cos square theta, and the last element is cos raised to 4 theta. And it is also given to us that this is equal to alpha into I plus beta into M inverse. Now they are asking us that alpha is alpha of theta and beta is beta of theta, which are real numbers, and I is your 2 by 2 identity matrix, which is 1 0 0, right? So further they are saying us if alpha star is nothing but minimum value of alpha and beta star is again minimum of beta, where this alpha and beta are composed of all the values for the angles from 0 to 2 pi, then it is asking us to find alpha star plus beta star's value. So basically we need to find the sum of minimum value of alpha I can have and the minimum value of beta. And four options are given to us. Let's see which solution fits for this question. So let's start with the solution first. Now, starting with the solution, first it is given to me that M is alpha into I plus beta into M inverse. Now, if you see the matrix M, this is a very lengthy matrix, so we don't need to find the determinant of that and everything. So what we'll do first of all is we do not need to find M inverse for this. What I'll do is I'll post multiply all the sides by matrix M again. So we will be post multiplying this by M. So post multiplying by matrix M. Now when I'm post multiply everyone by matrix M, this gives me M into M, that is M square. This becomes alpha. Now you know identity matrix into matrix M will become matrix M again. Beta, M inverse into M, right? So inverse of a matrix into a matrix is always an identity matrix. So I can write this M inverse into M as an identity matrix, right? So now, first of all, if I just find out M square, let's do that. So M square is nothing but multiplying M two times. So if I multiply two matrices, first was sine raised to 4 theta minus 1 minus sine square theta, 1 plus cos square theta, and this was cos raised to 4, right? So this was our M matrix. If I multiply this to get a square of that M matrix, sine raised to 4 theta minus 1 minus sine square theta, 1 plus cos square theta, and again cos raised to 4. Now we know that how to multiply the two matrices. So I'll take first row and first column and find that out. So it becomes sine raised to 4 theta into sine raised to 4 theta, that is sine raised to 8 theta, plus minus 1 into minus sine square theta into 1 plus cos square theta. So minus 1 minus sine square theta into 1 plus cos square. So this is my first element of the product of M square. So now next element, if I want, I will take first row and second column. So sine raised to 4 theta into minus 1 minus sine square theta. So minus 1 minus sine square theta into sine raised to 4 theta, plus again this gets multiplied with this, so minus 1 minus sine square theta and cos raised to 4 theta. Next element, second row with the first column, if I multiply, I get 1 plus cos square theta multiplied with sine raised to 4 theta plus cos raised to 4 theta I get multiplied with 1 plus cos square theta. Last element, 1 plus cos square theta gets multiplied with this. So it gives me 1 plus cos square theta minus 1 minus sine square theta plus cos raised to 4 theta plus into cos raised to 4 theta. So that gives me cos raised to 8 theta. So I get this product of the M into M, that is M square matrix, and that is equal to what? alpha into alpha into m plus beta into I. So now alpha into m is sine 4 theta minus 1 minus sine square theta 1 plus cos square theta and cos 4 theta. And that is added with an identity matrix and the product of beta. So identity matrix is 1 0 0 1. Right? Now I can equate this entire thing because it is given to me that m square is alpha into m plus beta into I. Now let's solve this further. So if I equate the first element of all the three matrices, so if I equate that first, I'll write it on the next page. It gives me sine raised to 8 theta plus minus 1 minus sine square theta into 1 plus cos square theta. That is equal to alpha into sine raised to 4 theta plus beta into 1, that is beta, right? So if I further solve or if I further try to solve this part of the question, it says sine raised to 8 theta plus, so minus 1 gets multiplied with this, so I'll get here minus, I'll erase this, so it gives me minus 1 minus cos square theta minus sine square theta minus sine square theta cos square, right? And this becomes alpha sine raised to 4 theta plus beta. So here from this equation, if I further solve this, it gives me alpha sine raised to 4 theta plus beta, that is equal to sine raised to 8 theta minus, if you understand this and this, if I take minus common from these two terms, sine square theta plus cos square theta is 1. So it becomes minus 1 minus 1. So it becomes minus 2 minus sine square theta, right? Further, if I equate the next elements, so if I equate this with this now, so it gives me 1 plus cos square theta, which is common in both of them. So I can take 1 plus cos square theta directly common. I will be left with sine raised to 4 theta plus cos raised to 4. So I get sine raised to 4 theta plus cos raised to 4 theta and 1 plus cos square theta common. That is equal to alpha into 1 plus cos square theta. So it gives me alpha 1 plus cos square theta plus beta, which is with 0. So beta into 0 will already make it 0. So this term is already gone. Now when this term is gone, if you see this term is present in both left hand sides and right hand sides, I can cancel this. So what I'm left with now is alpha is sine raised to 4 theta plus cos raised to 4. So I get value of one element out of alpha and beta, that is alpha is sine raised to 4 theta plus cos raised to 4 theta. So now what I can do is I can convert this into a perfect square, right? So I can write this as a square. I can write this as b square. Now when I have a square plus b square, if I want to convert it into a perfect square, I will have to add 2ab. So if I want to convert it into this, I'll add 2ab. So 2 sine square theta cos square theta I'm adding out. If I'm adding out something, I'll have to subtract that also. So minus 2 sine square theta cos square. So now that gives me, this becomes a square plus b square plus 2ab. So it is a plus b the whole square minus 2 sine square theta into cos square. So sine square theta plus cos square theta, that is 1. 1 square is 1 minus 2. I can write this as sine theta cos theta the whole square. Now you already know the formula from double angle that says sine 2 theta is 2 sine theta cos theta. So I can write sine theta cos theta as sine 2 theta by 2, right? So this becomes 1 minus 2 sine 2 theta by 2 the whole square. So it becomes 1 minus 2 sine square 2 theta upon 4. So this gets cancelled. Now what I get here is alpha is 1 minus half sine square 2 theta. So this is the value of alpha which we get, but we need to find the value of minimum alpha, or I should say alpha star. So alpha star is nothing but minimum value of alpha, means I need to put the value of some angle theta here so that I get the minimum value of alpha. Now if you see here, it is 1 minus some function, right? So 1 minus some function whenever it is there, and if I want minimum value of alpha, this part of the function should become maximum. And when this part should become maximum, this entire function should become maximum. And we know the maximum value of the functions for sine is, that is, sine 2 theta can be maximum 1 because the values of sine go from 0 to 1, right? So the maximum value of alpha I can get is 1. So if I put maximum value of alpha here, so it is sine 2 theta. If I put it as 1 square is 1. So it becomes 1 minus half, that is half. This gives me the minimum value of alpha, right? So we get the minimum value of alpha. Now let's find out the minimum value for beta as well. So if I solve for beta, I already know this. I'll use this idea. So alpha sine raised to 4 theta plus beta, I'll write it here. So alpha sine raised to 4 theta plus beta, it's equal to sine raised to 8 theta minus 2 minus sine square theta cos theta, cos square theta. So 2 minus 2 minus sine square theta square theta. Right? So now if I solve this further, I already know the value for alpha also, right? So I'll write that. Alpha in this case was, we got it as sine raised to 4 theta plus cos raised to 4 theta. I'll substitute that. So if I substitute here, sine raised to 4 theta plus cos raised to 4 theta into sine raised to 4 theta plus beta is sine raised to 8 theta now minus 2 minus sine square theta cos square theta. Further, sine raised to 4 theta into sine raised to 4 theta becomes sine raised to 8 theta plus sine raised to 4 theta cos raised to 4 theta plus beta is sine raised to 8 theta minus 2 minus sine square theta cos square theta. So if you see here, I can cancel sine raised to 8 theta from both of the sides. So I am left with beta as minus sine raised to 4 theta cos raised to 4 theta minus sine square theta cos square theta minus 2. So now what I can do is I can take minus common, right? Also, if you understand, I can see this sine square theta and cos square theta. Also, I can write this expression in this form of sine square theta cos square theta. So I can write this as sine square theta into cos square theta the whole square. I'll take minus common only. So I'm left with plus sine square theta cos square theta and plus 2, right? So I get the value of beta also. Now what I'll do is I'll put this sine square theta and cos square theta's product as some variable, let's say x. So sine square theta and cos square theta, I'm putting it as x. So beta becomes minus of x square plus x plus, right? So next, if I write it as, so I got beta is minus of x square plus x plus 2, where x was sine square theta into cos square. Now we already discussed one idea for double angle, that said sine 2 theta is 2 sine theta cos theta. So if I want to write sine theta into cos theta, I can write it as sine 2 theta by 2 the whole square. So x becomes sine square 2 theta by 4. So if I write it here now, I want the minimum value for beta as well, right? So minimum value of beta I can get here is, if I know sine 2 theta can be from 0 to 1. So if I take the square of that, or it can be minus 1 to 0, anything, right? So sine square 2 theta can go from 0 to 1. So if you see that, the value of x I can get is either 0 by 4, that is 0, or I can get 1 by 4, that is 1, right? So I can get two values of x from 0 to 1 by 4. So I need to find out minimum value of beta, and beta when it is negative, I should take the maximum value of x here out of 0 and 1 by 4, and the maximum value I have here is 1 by 4. So I'll put here 1 by 4 because it is present with a negative sign. That becomes already a minimum value, that is the lowest value. So minimum of this becomes 1 by 4 square, this becomes 1 by 4, and this becomes 2. So this gives me minus 1 by 16. 1 by 4, if I want to make this denominator also 16, I'll multiply by 4. And if I want to make this denominator also 16, I'll multiply by 32. I'll multiply by 16 on both sides, so it becomes 32. So it gives me minus 32 plus 4, 36 plus 1, 37, and it becomes 37 by 16. So I get minimum values for both alpha as well as beta. So minimum value of alpha which we got was half. So minimum value of alpha which we got was half, and the minimum value of beta which we get here is minus 37 by 16. So if I make the denominator same again, I'll multiply by 8. So 8 minus 37, and that becomes minus 29 upon minus 16. So that gives me the minimum value, or the sum of the minimum values of alpha and beta is minus 29 by 16. And if you see this with the option, it matches with option B here, right? So the correct answer for this question is option B. I hope you understood how to solve this type of question where minimum is asked for the angles going from 0 to 2 pi. Right? I'll meet you again tomorrow with the next question. You can like, share, and subscribe if you find this really helpful. Thank you.